cool. So looking at this little, we're going to use this one for our example as well. So NH3 is technically ammonia, not ammonium. Ammonium had NH4 with a positive charge, okay? But ammonia, nitrogen trihydride, which one do you think is the central atom? Nitrogen. I think you said hydrogen. I'm going to ignore that. All right, because it's the most unique. And also, no hydrogen ever. Okay? Don't pick hydrogen. Can't go in the center. You'll run out of spots. Okay, cool. So now I'm going to use this time to start talking about NAS. So I kind of wrote this here as a reminder to stop here and make sure that we're going to talk about it. So we are going to write a little bit. I will try to go slow so that you guys have the time to kind of write it in as we're talking about it. So before you use NAS, so you guys being advanced, like I said, I'm going to require this. It'll look a little tedious at first, but once you get the hang of it, you're gonna start reducing the steps and you won't need it as much. But the thing about NAS is that it will tell you when you need a single, double, and triple bond without you having to think too hard about it. All right, and it'll make your picture perfect the first time around. You don't have to like sit there and do squiggly lines and then redraw it. Okay, so that's why I usually teach this. So the first thing you have to do before you even start doing that is you pick your central atom. So no matter what, you got to run through the steps to pick your central atom. I'm just writing this right above here. Okay, so we're going to be using NH3 as our example. So what I'm going to recommend is right here next to where we crossed out H, write an N and 3 H's. And give yourself a little bit of space over here. Okay? So out of those 3, we picked nitrogen. So just circle that one so that we know we did that first step. So first you always pick your central atom. Then we start the NAS process, okay? And the NAS process, it's going to be a little bit of a calculation, but we'll run through each step as I write it down. All right, so N. N stands for needed, which bothers some people, so we're going to write what does that mean. It means what is the max. What I mean by the max, I mean the octet. What is its octet? What is its requirement to be full? Not how many does it need. It means how many does it need total, all right? Some people like to say, well, it only needs 3. No. Total, okay? So for the most part, this is 8. This will always be 8, except for the ones that we just talked about. So let's do that step. So we're going to put an N right here because we're going to do our steps. So for nitrogen, how many does it need to be max? Or what is its octet? Nitrogen. Nitrogen? 8. Right? Okay, what is it for hydrogen? It's not 8. You wrote it right here. It's 2. Good. So each of these hydrogens are 2. So just go ahead and put 2 plus 2 plus 2. Add those together. 8 plus 2 plus 2 plus 2 is 14. Good. Okay. So we got our needed step done. Let me give you a second to write that in. Does anybody have any questions over the needed step? Okay. All right. So our next thing is A. A stands for available. What do you think that one is going to be? Has to do with electrons. How many what? Okay, so it's even going to be easier than that. So you don't have to figure out right away how many spots it's going to bond on, because we're going to take care of that in that last step. What it is but it's kind of related to that. It's how many valence electrons. How many electrons does it have available to offer this picture, right? So it's valence electrons, and how are we going to find those valence electrons? On the periodic table, you got your group number, right? And remember on the blue ones, it's the ones that have the A's next to them. All right, so we're going to do the available step. So we have nitrogen. Nitrogen is right here in group 15. So it has a 5A next to it. So how many valence electrons does nitrogen have? 5. put a 5. How many valence electrons does hydrogen have from group 1? 1. 1, 1, 1. We're going to add those up. What does that equal? 8. Good. Okay. So the next part is the shared part. And if you notice, it was a subtraction thing. That's because we are going to subtract. So shared. Okay, shared electrons. So if I tell you that you have 10 electrons that are being shared, how many bonds does that have? Think about that question. If you have 10 electrons being shared, then how many bonds are there? 5. What math did you just do? Yeah, because there's 2 in every single bond, right? So we're going to be dividing it by 2. So you're going to take your shared electrons, you're going to divide that number by 2 to figure out your number of bonds. Okay? Just so you know. All right. So let's handle that. We're going to be subtracting these 2 to get S. Don't have to write anything here. We're just going to do this math. 14 minus 8, what does that equal? 6. Okay, so we didn't have to write anything down here. So 14 minus 8 is 6. That means we have 6 shared electrons. So what are we going to do with that 6? Divide by 2. How many bonds does that just give me? 3 bonds. All right, perfect. So now I am set up for success in order to do this. We've already determined who's going in the center. So we're going to go ahead and draw nitrogen. Use that capital letter. How many lines am I going to put around nitrogen? 3. Good. So we're going to spread them out like that. We know that it can fit 8, so we don't want to spread them out like perfectly. You'll see the ones that you're going to have to do that on. We're going to have 8. Okay, your last step. Once you've done these things, go back to A, or available, and count. All right, so A, available. What was our number that we needed for A? What was that number that we added them up to be? 8. Okay, how many dots do each of these lines represent? 2. You can even give yourself dots on the ends if you want. So 1, 2, 3, 4, 5, 6. We should have available in our picture 8. Am I correct? Okay, so we're going to have to do that. I totally forgot one step though. I'm sorry. What did I not add to the picture yet? Hydrogen. Yeah, let's go ahead and throw hydrogens on the ends. I'm sorry. I totally skipped that. All right, now going back to the dots. All right, so we need to have 8. We have 6 so far. We have 2, 4, 6. So what are we going to put the last dots on? Can they go on hydrogen? No, right? They're done. Who's it going to go on? Nitrogen. You're going to put the 2 dots there. It's a lone pair. Okay? There's your drawing, and it's done. Now, does this look a lot more elaborate? Yes, yes. Typically, a lot of people teach it, connect the dots, and that's fine. However, you won't know when to do the 4 or the triple bonds and double bonds. So I want you guys to try. So what I assigned to first period today was I want you guys to try NAS on this one.